Hello, in this lecture we will see about relations as part of our course Mathematical Foundations of Computer Science. So, till now we have studied about sets and we have seen functions. So, the last concept in unit 1 of the course Mathematical Foundations of Computer Science is relations. Let us try to see. Relationship between elements of two sets are represented using a structure called a binary relationship. See, you have studied about sets. We have sets like this A, B, C, and we have another set, assume 1, 2, 3. So, when you have two sets, you can form a relation between the elements of the sets, elements of both the sets. Like I can form a pair of elements like A comma 1, B comma 2, C comma 3. This forms a relation between A and 1. It means A is related with 1 or 1 is related with A. So, we are trying to combine or form a relationship between two different elements of two different sets. Or I think this also can be called as a subset of Cartesian product. If you remember, in two sets when we write Cartesian product of A cross B, so we write here ordered pair of elements like A1, A1, A2, A3, B1, B2, B3, C1, C2, C3. We formed a Cartesian product. So, a relation between two sets is nothing but a subset of that. Okay, we will see some examples. This is very important concept in computer science. It's a part of mathematical subject, but still this is used. One best example is from tables in SQL or DBMS course. If you study, we have student table, we have faculty table. Some students, this is faculty, some students register courses under faculty and some faculty teach to some students, right? So, if I want to find out something which is linked to both the student data and the faculty data, I have to join them. I have to combine these two sets. So, assume this is one set and this is another set, we are combining them. So, we say there exists a relationship between the student table and the faculty table. So, the relations concept is mostly used in database management system. Also, it can be used to solve problems such as determining which pairs of cities are linked by airline flights in a network. So, if you want to know which all pairs of cities are linked with airline in a network, that also can be formed using relations. See, that's what I was talking about. SQL tables we use to combine. When you want to join multiple tables, we have to use concept of relationships. Okay. Next, why it is called binary relationship? Between two different elements of two different sets. Let us see definitions. Let A and B be two sets. A binary relation from A to B is subset of A cross B. This means Cartesian product. So, a binary relation is a subset of the Cartesian product A cross B. In other words, binary relation from A to B is set R of ordered pairs, where the first element of each ordered pair comes from A and the second element comes from B. So, when you are forming a relation A, A comma 1 in a relation, this is from set A and this is from set B, and it is an ordered pair because we are writing in order. First A set element, then B set element, first A set element, then B set element. That way we are writing them in order, right? So, we use the notation relation A relation B. We write A R B denotes that A comma B belongs to relation R, and if I write A cross mark B, it means A comma B does not belong to the relationship R. So, let A be the set 1, 2, 3, 4. Which ordered pairs are in relation R? Okay, which ordered pairs are in relation R? So, from this set A, 1, 2, 3, 4, we have to form ordered pairs. How to form? The condition is A divides B. So, you can write here the relation R equal to, in brackets, see, 1 divides 2, yes, 2 by 1 is possible. So, 1 comma 2 is one pair. 1 divides 3, so 1 comma 3 is possible, right? 1 divides 4, 1 comma 4 is possible. Then 2 divides 3, no. 2 divides 4, yes, 2 comma 4 is possible. Then 3 divides 4, no. So this is the relation. The relation here is that the element A divides the element number B. Okay, so this is called a binary relationship. So how many such relations can we form when we have a set with n elements? Is 2 power n square, 2 to the power of n square relations we can form with a set of n elements. Now let's see some properties of relations. The very important one is reflexive. Okay, a relation R on set A is called reflexive if A comma B, A comma A belongs to R for every element A belongs to A. Reflexive means I should have its image. So if there is a set 1, 2 and 3, okay, and there is a relation R which contains 1, 1, 2, 2 and 3, 3 as the elements. If that set, if that relation contains many relations exist in this R, many ordered pairs are there in this, but it should definitely consist of 1, 1, 2, 2, 3, 3. That's what A comma A belongs to R. Then we say this kind of a relation R is called reflexive relation. See, now given example here, we have set 1, 2, 3, 4. Find out which among R1 to R6 is a reflexive relation. So how do you found it? Let's take an example. Let's take the first one. Is it reflexive or not? See, there are 1, 2, 3, 4. It means we should have 1, 1. We have 1, 1. We have 2, 2. We have 4, 4. But no 3, 3. So this is not reflexive. R1 is not reflexive. Second one, you see, I have only 1, 1, 1, 2, 2, 1. 3, 4 is missing. So this is not. If you take R5, let's jump into R5 or R3, let us take. We have 1, 1, 2, 2, 3, 3 and 4, 4. Therefore, R4 is reflexive. R4 is a reflexive relation. Okay, that way you have to find out for a given set, set of ordered pairs, which relation R is having the reflexive property. What is reflexive property? If there are 4 elements, then there should be ordered pair with the same element. Okay, like this 1, 1, 2, 2, 3, 3, 4, 4 because we have 4 elements. The second property is symmetric. Symmetric means if A comma B belongs to a relation, B comma A should also belong to the same relation. It means if I have an ordered pair 1, 2, I should have 2, 1 in that. If this kind of ordered pairs exist, we say that relation R is called a symmetric relationship. Let's see some example here. See, consider the following relationship 1, 2, 3, 4. So if you take this 1, 1, okay, 1, 2 fine, 2, 1 is also okay. 2, 2 means 2, 2 is fine. 3, 4, but there is no 4, 3. See, 3, 4 exists, but there is no 4, comma 3 in this set. So R1 is not symmetric. You take R2. Is R2 symmetric? Yes, 1, 1 and 1, 1 it's self symmetric. 1, 2 and 2, 1. This is symmetry because in that set there exists its pre-image. You take maybe if I take R4, 2, 1 exists, but 1, 2 is not there. 3, 1 exists, but 1, 3 is not there. So this is not a symmetric relationship. Take R5, 1, 1, 2 and 2, 1 is not there. So this is also not your symmetric relationship. Okay, so that way you have to verify which all is a symmetric relationship. So R2 is symmetric here because when the elements available, its reverse is also exist. If A comma B belongs to R, B comma A should also exist in the same relationship R. Third one, transitive. It's very easy and simple. You might have already studied it many times. A comma B belongs to R and B comma C belongs to R. Then A comma C should also belong to R. It's like A to B and B to C. Therefore, A to C. Transitive relationship. So, if there exists any relation R which contains all these 3 pairs 1, 2, 2, 3 and 1, 3. Okay. If there is 1, 2, 2, 3 and also 1, 3, then we say that particular relation R is called a transitive relationship. From this, if you identify, we have 1, 1, 1, 2, therefore 1, 2 exists. 1, 2, 2, 2, therefore 1, 2 exists. 1, 2, 2, 3, 1, 3 exists. 1, 3, 3, 4, 1, 4 exists. If you see, so R5 is a transitive relationship. That way you can verify whether all these sets R1, R2, R3 are transitive or not. The last important concept here is equivalence relationship. If any relation R, which is all three, reflexive, symmetric and transitive, that kind of relationship is called as equivalence relationship. If you see here, if it is reflexive, symmetric and transitive, then we say it is called as equivalence relationship. So find out whether this is equivalence relationship or not. So you see, I have 1 1, 2 2, 3 3 and 4 4. This is reflexive. Reflexive is satisfied. Next, symmetric. I have 1 2, 2 1. I have 1 3, 3 1. I have 2 3, 3 2. Right? This is again symmetric. Transitive, you find out whether it is transitive or not. You take 1 comma 2 and 2 comma 3. 2 comma 3. Therefore, we have 1 comma 3. Yes. That way, if you verify, all three exist here. It is also transitive. Then we can say this relation R is called a equivalence relationship. Okay. So we have studied about reflexive, symmetric, transitive, and equivalence relationship. And the last concept is composition of relations. Right? Like we are forming a composition of functions. If you see in the previous lecture, we have studied about f of g of x. This is composition of two functions, f of x and g of x. We are combining. Similarly, we are having g of f of x. So we are combining these two, right? Same way, you can also form composition of relationships represented like this R of S, this O symbol. Okay. So see the example. I have a relation R with 1 3 2 1 4 3. I have another relation S with 1 2 2 3 3 4 4 3. What is R composition? Yes. See, you have here 1 3, then we have 3 4. Therefore 1 comma 4. Then you have 2 1 and 1 2. Transitive relation. You apply transitive relation here, but the paired ordered pairs are from two different sets. For 2 1 1 2, I will write 2 comma 2. Then 4 3 3 4, I have 4 comma 4. So this forms our composition. See the solution? We got the same thing. Okay. R of S, like we write f of g, we write R of S here, composition of two different relationships. So with this we complete our relationship chapter. So in the next lecture we will start with our unit 2, that is propositional logic. Thank you.